Hi guys, we're back with another video about the nervous system. This time we'll be getting into the different parts of the organ or of the nervous system, how it's organized, and specific functions of each of the breakdowns within the nervous system. There's a lot here. There's a lot of terms, so make sure that you are taking notes and are ready to go. If you haven't watched the videos about neurotransmission or the neuron, you need to go back and watch those. This is assuming you know how all of that stuff works. Okay, so all of the neurons in our body are connected to the nervous system in general. And the nervous system can be broken down into a number of different subdivisions that each have their own special function. So first, let's look at that overall function. So the nervous system can really be divided into two main parts: the central nervous system and the peripheral nervous system. The central nervous system is made up of the brain and the spinal cord, and the peripheral nervous system is also broken down into two parts: the autonomic nervous system and the somatic nervous system. The autonomic nervous system is broken down into two parts: the sympathetic and the parasympathetic, and the somatic nervous system is broken down into two parts as well: afferent and efferent nervous systems. So there's a lot here. There's a lot of breakdowns. There's a lot to keep track of, but it's important that we have this kind of all ready to go so that you know what each of the parts do and how they function. Okay, so let's start with the central nervous system. Okay, the central nervous system is the brain and the spinal cord. Notice it's not the spinal column, right? So the spinal cord is the series of nerve fibers that are bound together that come out of the base of the brain. Technically speaking, these are the same thing. There's no real biological difference between the central nervous system and the spinal cord. Just to go to show how important the central nervous system is, it is the only part of the nervous system that is encased in bone. So the spinal column covers the spinal cord, and obviously our skull covers our brain. Only at certain parts of the neck where the spinal cord itself is visible, which is why injuries to the head and neck are so severe and can have such life-threatening consequences. So the central nervous system is what sends information and receives information to the rest of the body. This is where decisions are made. This is where, that's just where decisions are made and how information is routed. Okay. The peripheral nervous system, on the other hand, is essentially the rest of the nervous system in the body. So the two smaller units, which sometimes run along the same nerve fibers, right? So sometimes they're kind of running along the same thing, are the somatic nervous system, which deals with sensation. So this is information coming from the body and going to the central nervous system. Okay, this is really, really important, guys. Sensation, whenever you hear sensation, it is always about a feeling, right? The sensation coming from the body or the external world into our nervous system, right? It is. Remember, this is all just a series of communications, right? So, sensations, you can think of it as with our senses, right? What are our five senses? We actually have more than that, but we'll get into those later. So what you're seeing is part of your somatic nervous system, right? You have your optic nerve, right? Just your nerve endings, which then translate that information to your central nervous system. The fact that you can feel something on your skin, right? That information is going from your skin to your central nervous system via the somatic nervous system, part of the peripheral nervous system. There's a lot there. The other thing the somatic nervous system does is it also deals with movement. Okay, voluntary movement. So I decide to move my arms, right? That's voluntary movement that is also controlled by the somatic nervous system. Look at the root word of that, soma. We've talked about that with the neuron, right? Means body. So somatic nervous system means the nervous system within the body. Okay. The other branch of the peripheral nervous system is the autonomic nervous system. The autonomic nervous system deals with regulating our body. Okay, it's kind of like the automatic, right? It's not quite the same word, but it's kind of like an automatic thing. So the autonomic nervous system is responsible for things like your heart rate, or your breathing, or how much you're sweating, or your pupil dilation, or whether or not your stomach is digesting food or not. Um, so that is what your autonomic nervous system is in charge of. Remember, all of that stuff is regulated by your brain. So the stuff that's kind of running in the background is your autonomic nervous system. And the sympathetic and parasympathetic each have opposite jobs to do when it comes to regulating our body's physical responses. Okay. So let's just go peripheral nervous system. So again, the somatic nervous system is the body's nervous system, right? It is what connects the voluntary skeletal muscles and sensory receptors in our skin and our other, sense organs. So they take the information from where they're getting it, skin, muscles, joints, whatever, and sending it to the central nervous system, and from the central nervous system to the skin, the muscles, and the joints. The autonomic nervous system controls our involuntary, kind of visceral reactions that people don't normally think about. So the autonomic nervous system is made up of a series of nerves that are connected to the heart or the lungs or the stomach that help control and regulate those types of things. So let's dive deeper into the autonomic nervous system. Let's dive deeper into the autonomic nervous system. So here you can see both the parasympathetic and the sympathetic nervous system and how they regulate our, visceral reactions. Okay. If something happens, and in psychology, we use the term arousal, right? So if something happens that startles you or produces a strong feeling, right, a strong emotion, we call that arousal. Doesn't always mean sexual arousal. So when you're terrified, someone jumps out at you, or you're in a scary situation, your heart starts racing, you start sweating. These are the reactions of your sympathetic nervous system, or the sympathetic division of your nervous system, right? Your digestion slows, your breathing picks up, right? This is a kind of when you have an adrenaline rush, this is what happens. Your mouth goes dry, your pupils dilate. Also, notice on there is bladder relaxed. So that's why some people, it's kind of a stereotype or whatever, but they have, accidents. They wet themselves, right, when they're really scared, because their bladder relaxes and it releases the urine that has been stored there. So that's just how the nervous system works. That's the sympathetic part of the nervous system. Imagine that you're in a fight or flight situation where your survival will depend on it, right? Having all of your breathing speeding up, your heart rate speeding up, it's diverting energy to the things that will help you survive. Now, you can't operate that way forever. So if someone were to jump out at you and scare you and your heart starts racing, it would be really bad if your heart never slowed down, right? Just kept pounding in your chest. You would eventually have a heart attack. So the parasympathetic nervous system is what slows everything down. So you have these competing kind of edges. You have the sympathetic nervous system, which kind of revs you up for the fight or flight response, and the parasympathetic nervous system, which kind of cools you down, right? The way I think about it is parasympathetic kind of is similar to like paralyzed, right? It slows things down. Para also means stop in Spanish, as like a command, I believe. Maybe I'm making that up, but that's another way that if I am making it up, either way, it helps me remember that. So sympathetic nervous system increases the things it does the things on the right hand side of the screen, and the parasympathetic does things on the left hand side of the screen. Okay. In the somatic nervous system, there are two types of neurons. So remember, we said the somatic nervous system deals with sensation and voluntary movements. So this sensory neurons, which deal with sensation. So this is what allows us to receive information from the environment into our central nervous system. Those are called sensory neurons because they deal with our sensations. The motor neurons, which deal with movement, right? Because motors help you move. That sends information from the central nervous system to the muscles that then allow the movement to take place. The downside here is that sensory neurons are called afferent neurons and motor neurons are called efferent neurons. I have no idea why they made them so similar, but don't worry, I have a mnemonic device for you. Sensory neurons are afferent neurons. Motor neurons are efferent neurons. If we take the first letters, you have S, A, M, E, same. Will help you remember that the sensory neurons are also called afferent neurons, SA. Motor neurons are efferent neurons, ME, SAME, same. So remember same when we're talking about the somatic nervous system. So now that we have just kind of, let's go back to the central nervous system here. So again, the central nervous system is encased in bone, which highlights the importance of it. And also, it is protected by other types of sheaths that are called meninges, which is where we get the term meningitis, and cerebrospinal fluid as well, which provides kind of a cushion. So your brain is kind of like floating within your skull a little bit. That's why concussions happen, right? It's not fully packed up, right? The brain bounces off against the inside of the skull. Okay, so structure of the central nervous system. Again, we're kind of getting into a lot of this stuff. So structures that are more posterior or towards the bottom of the central nervous system, so that would be at the like kind of base of the spine, are tend to support simple reflexive behaviors and also the basic functions of life. So that's kind of the issue there. So the bottom end tends to deal with that. The structures that are more anterior or toward the front of the central nervous system tend to support complex cognitive and sensory processes, which would be like in the brain. So again, that's why a spinal cord injury can have such devastating effects. That's why someone who breaks their neck can die, because the bone that has broken in the neck could sever the spinal cord, which then can cause death, especially towards in the neck area. But everything needs to communicate together quickly in order for information to be shared. Let's talk about reflexes. Let's talk about reflexes for a second. So we all know the reflex in our knees that cause us to kick out when we have when we're at the doctor's and they're doing a physical, right? So if you tap the knee on the right spot, it'll cause the leg to kick. How does that work? Well, when the hammer hits the knee at the right spot, it then triggers a neural an action potential. It triggers a neuron to depolarize, and it sends that information, which is from a sensory neuron, from the leg, from the skin of the leg and the muscle in the leg, to the spinal cord. Okay? As that information comes in the spinal cord, a few things happen. One, there's a transfer of information. So this is all along one axon, right? So this is one nerve. This is why it's so quick. And then it goes to the spinal cord. Some of it then gets routed up to the brain so that the brain can go, oh, someone just hit my leg, right? You can be aware of that sensation. Some of it in the shortest pathway, all the way to the left of the image there, in the spinal cord, it just spins right around and goes right back out to the motor output within the spinal cord and causes the kick. That's why it's called a reflex, because it really happens slightly before your brain is aware that you just got hit in the leg, which is why you can't fake a reflex like that. It would be delayed. It would be too intentional. It just doesn't work. So it's also why you can't prevent it from happening. If you try to sit there and block it from happening, and the doctor hits your knee in the right spot, your leg's going to kick no matter what, because it happens before your brain's even aware of it. And also the kind of cool thing is if you have both of your legs kind of dangling off the chair, your other leg will move a little bit too, because there's a neural connection to the other leg in the spinal cord. So I'm highlighting it here because you'll notice that it says a single synapse in the reflex. So the reflex, it's one neuron communicating to another neuron. It's the fastest it could possibly be. And that's what causes the knee kick reflex. Let's also, we'll kind of stop with this next point here about the central nervous system and how it works with neural networks. So neurons are connected to many, many, many other neurons. And these interconnected neurons form something that we call a neural network. Neural networks allow for the faster transmission and sharing of information than single neurons by themselves. This is what allows us for more complexity, because the more that neurons communicate with each other, the more information they're able to share, the greater detail they're able to provide. This thing happens over the period of continual firing. So the phrase I like to say is neurons that fire together, wire together. That as they become more entangled, that allows for faster communication between them because they've communicated so much in the past. It's almost like they're a trusted partner. So the information just flies right through the neural network. This is also kind of related to muscle memory. So, trying to do, if you've ever tried to like tie your tie in a different way than you normally do, right? It goes from something that was automatic to something you really have to think about, right? Well, why is tying your tie automatic? Neural networks, right? That kind of run an autopilot. So neural networks are extremely important for understanding of how our complex mind works, that our brain is just really huge connections of neural networks. We're talking in the billions and trillions of cells that are connected together. And it's what allows for our rich, mental life. I do want to move on to the last thing here because it's the last part of this segment, and that is to talk a little bit about the endocrine system. So the endocrine system is also a communication system within the body, but it's different from the nervous system. The nervous system is extremely fast, right? Think about, we're talking about the speed of neurotransmissions. We're talking, milliseconds or nanoseconds. The endocrine system is a lot slower. It also works with chemical messages, but instead of it being in the nerves or nervous system or cerebrospinal fluid, they travel in the bloodstream. And the chemical messages all start in a certain area. We have different glands that transmit different hormones through the bloodstream. So we have hormones like testosterone or insulin or adrenaline that are, like growth hormones in the thyroid, those kinds of things. These are all glands that send information through the bloodstream and impact our entire body, okay? Sometimes it takes seconds. So this is a lot slower. If we're talking nanoseconds to actual seconds, right, that's several orders of magnitude slower than the neurons can. You will need to know some of the breakdowns of the endocrine system, which I have a diagram in a second, but you need to know that the adrenal glands release epinephrine, or adrenaline as it's called. Now notice we also have something called norepinephrine. That is a neurotransmitter, right? So these are they're essentially chemically identical. It's just one is found in the nervous system, one is found in the bloodstream. The pituitary is the master gland, which is controlled by the part of the brain called the hypothalamus, which is its main job is to monitor the endocrine system and make sure that our hormones are all staying in the right place. So this is where the connection between the endocrine system and the nervous system take place. So the brain, when it says, hey, we need more adrenaline or epinephrine, or we need more testosterone, the brain tells the pituitary gland through the hypothalamus, hey, go tell the adrenals to produce epinephrine. So pituitary gland then sends information through the bloodstream to the other glands. It finally gets to the adrenals. They say, oh, let's send out the adrenaline that the brain needs, and it sends it out, and it goes to all parts of the body. Your heart starts racing. You're feeling the adrenaline rush. And then as it goes back up through the bloodstream, it goes back into the brain, where the brain can say, okay, that's enough adrenaline. We're good. Or keep going, keep producing the same amount, or we need more, keep more coming. And this shows the connection between these two things. Another way to think about this is that not only is it slower, right? It is a lot slower, but it's also more similar to, there's also longer lasting effects of the endocrine system. It takes longer for the effects to wear off than it does in the nervous system. It also is not as targeted. So the way I like to think of it is, if I need to send information, if I'm the nervous system, it's like a text message. I send it right to someone that I need to. Hey, this needs to happen. Make it happen. But for the endocrine system, it's almost like they're putting an ad out in a newspaper and hoping that the newspaper gets delivered in the right spot. It goes through the whole bloodstream and affects the entire body. So adrenaline has an impact on things like your stomach or your intestines, even though it really has nothing to do with that, but it has an impact. And too much adrenaline in your system for too long can produce negative things like ulcers and those kinds of things. Here's a breakdown of the endocrine system that glands that you're going to need to know. The thyroid's in the neck. Adrenal glands are on top of the kidneys, or renals, right? There's the islets of Langerhans, which is the pancreas, and then you have the sexual ones, the ovaries and the testes, that are also part of the endocrine system. So this is important for you guys to know too. It's not just all about the nervous system here. The endocrine system is important as well in terms of how our bodies respond to things, stressors or whatever in the outside world. All right, that's long enough. We're going to stop here. Next video is going to be all about the brain and the parts of the brain and how the brain functions. So stay tuned for that. See you guys later.